In this video, I'll give you some tips for post-lab for acid-base titration practice. Most of the questions on this post-lab are just in the form of data tables. You'll be doing quite a bit of calculations. The first thing that you need to do is write a balanced equation for the reaction between NaOH and HCl. Those are going to be the reactants, and then you need to predict the products of this reaction. This is an acid-base reaction. HCl is the acid and NaOH is the base. If you're having a hard time predicting the products of this reaction, you can probably use the internet to help you figure them out. Once you get the products figured out, make sure that you also balance this equation. Data table number 2 is going to have to do with HCl that you used in the experiment. For the first row, you're going to be reporting the molarity of the HCl. This is going to be given to you on the bottle of the HCl in the software. So you'll need to look that up. Look at the bottle to see what it says, and it's the same for both titration number 1 and 2. It's the same molarity for both of them. The lab instructs you to use 25 milliliters of HCl for this experiment, so that's been written in there for you. And then in this box, you're going to convert that volume into liters. To convert from milliliters to liters, you're going to take your value in milliliters and just simply divide it by 1,000, and that'll give you your value in liters. And then down here, last but not least, you'll calculate the total moles of HCl. So the way that you're going to do this is take the molarity of HCl, I'm going to write the word out instead of using the abbreviation, and then recognize that the molarity of HCl is just simply the number of moles of HCl in every 1 liter of HCl. So whatever the molarity is, whatever this number is, that's how many moles you have per liter of HCl. And then what you'll do is multiply by the volume of HCl that you used in the lab in units of liters. So the molarity of HCl, which you got from the bottle, which goes in this spot right here, times the volume of HCl in liters that you calculated in this spot, that's going to give you the moles of HCl, which you'll put in this space. Data table number 3 is really similar. You've got the molarity of NaOH that you will be reporting from the bottle of NaOH in the lab. For this one, you don't have a predetermined volume. So for the HCl, you were specifically using 25 milliliters. For the NaOH, don't know how much you might be using. The burette started at 0 milliliters. You will write down the final burette volume at the end of the titration. The total volume that you dispense is just the difference between the initial volume and the final volume. And since the initial volume is 0, this is really easy. Then you're going to convert that milliliter into liters by dividing by 1,000. Again, you're doing your total volume, so you want the total volume to convert into liters. And then you'll do a mole calculation again. Same method as what you use up here. You're going to take the molarity of your NaOH and multiply it by the volume in liters. So the molarity of NaOH multiplied by the volume in liters, that goes in that box right there. Now you are going to do some calculations on the accuracy of your titration technique. So you're going to start by reporting the total moles of NaOH. This says it's coming from problem number 2. So you'll go back to problem number 2. I'm sorry, I said NaOH, HCl, total moles of HCl. You'll go back to problem number 2 and you'll take your total moles of HCl from this box right here, from these 2 boxes right here, and you will just copy that into this spot right here. So you're just copying it. And then you're going to calculate the theoretical moles of NaOH. This is a calculation. Calculate. Now to do this calculation, you are going to be using that balanced equation that you did in problem number 1. You will have NaOH plus HCl, and you will have predicted the products of this equation. I'm just going to write product and product. And then you are going to balance this equation, whatever these stoichiometric coefficients might be. Once this equation has been balanced, you are going to use the total moles of HCl that you've measured out in the lab, and you're going to use that to figure out the theoretical moles of NaOH, again, from the balanced equation. So let's say that after you balance the equation, let's say that you have 2 moles of NaOH and 1 mole of HCl in your balanced equation. If that was the case, you would take your moles of HCl, that is this number right here, your total moles of HCl, and you would want to multiply that by a conversion factor that has moles of NaOH on top and moles of HCl down on the bottom, so that the moles of HCl can cancel. And in this, you'll be using the stoichiometric coefficients from the balance equation. So you'll be using 2 and 1, if that's what the coefficients are. Whatever the coefficients are, you're going to fill it in there. You'll do the math on that, and that's going to give you these numbers right here, the theoretical moles. The actual moles of NaOH, this is going to be the numbers that you calculated from your data. So in these two boxes, total moles of NaOH, this is what we are calling your actual moles. This is how much you actually used. You'll copy that into this spot, and then you'll use this equation right here to calculate your percent error. You're going to plug in your actual moles and your theoretical moles of NaOH. So both of this is for NaOH. This one is also for NaOH. We're not using moles of HCl in this equation. Divided by your theoretical moles of NaOH, that'll give you your percent errors.